Okay, so I'm going to try to do 3.5 question 8. So my problem says the half-life is 24,100 years, and it wants to know the initial quantity after 2,000 years when zero point 0.6 remains. And so the model that we're using is P equals P naught E to the RT. So if you're not familiar with half-life, what we do is we take that model and we can say the amount of time it takes. We're basically looking for the amount of time it takes for the initial amount to reduce itself to 1/2. So that's why we replace the left side with 0.5 P naught, which is the initial quantity. So since I have P naught on both sides, they cancel, and I have this expression. Then I can take the natural log of both sides of the equation. After I take the natural log on the right side, the natural log of E, all I'm left with is the RT. So now I have this expression, and then I can go ahead and solve for the rate, R. So I know that the rate's going to be the natural log of 0.5, there should be a point there, over T. And for this problem, we know that the half-life was given as 24,100, so I can plug that into this equation. So whenever we solve this problem, this is going to be our rate. Now, so moving towards our problem solution, again, we're going to go back to our model, and we want to know what P naught is when our population is 0.6. So we're going to say 0.6 in for P, this is my unknown, E to the R comes from this times T, and that T comes from 2,000 years, which was given. So then basically we just have to start moving some stuff around and get P naught by itself. So this is the expression. We're going to divide both sides by E to this mess. And then I see I have 2 zeros here, 2 zeros here. So my simplified expression, this is what I got to punch into my calculator. So I'm going to go over here, and I'm going to turn my calculator on. And I'm going to go ahead and I'm going to, excuse me for 1 second while I get everything arranged here. Okay, so you can see on my screen, hopefully it's showing up for you. I don't know why. Everything is kind of backwards for me. Okay, so here's where I plug in 0.6 e to the 20 times the natural log of 0.5 divided by 241, and I get 0.6355, and you can check my answer, and it says that the answer is 0.64. So I'm going to send you a message with a link to this video along with a picture of the problem. So hopefully that helps. Thanks.